When you say model quality, how do you break that down? Based on like dimensions, I guess.
Yeah, I'd say there's about 5 dimensions that we think about. So first is we think of kind of conceptual soundness and model reliability. So this is where there's kind of a risk of being weakness in the performance of your model in the real world. This could be because the model, because of bias in the training data, has not really well understood how you should think about a particular feature. Like in a credit decisioning model, for example, we have a public data set we use in order to build credit decisioning models. And in this data set, there's this weird situation where there's a set of users that have particularly high debt to income ratio, but they're viewed as low risk by the model. And that's because there was kind of an actual issue in the data quality. There's another piece where somehow the model views people with income of $125,000 to $150,000 of income as being less risky, as being more risky than people with $100,000 to $125,000 of income. Those are examples where overall the global accuracy metrics are pretty good, but when you look at these more micro slicing levels, you see that there's real weaknesses or problems. There are other situations where your model could be making a strong statement, but actually not be very confident about that statement. All statistical models have confidence bounds, for example. So that's one area, conceptual soundness and model reliability. The second is about explainability and enabling in human and machine collaboration. So how can you explain how your model works to stakeholders? The third is in bias or unfair bias. The fourth is in looking at the segment level versus just at a global level. In any kind of application in business that you're applying your machine learning model to, there's always going to be segments of the business that are more important than others. In a lot of businesses, there's a small percentage of the customer base that drives a lot of the revenue or a lot of the profits, for example. So I remember I was working with, Neiman Marcus in one of my prior companies, and they kind of cater to high, very wealthy individuals. But even then, there was a small set of users, of customers that actually drove a vast set of their kind of profits. So that segment is going to be more important. And if your model doesn't do a very good job on that segment, then even though it does a really good job globally, then that can also be a problem. And the fifth area is really about model stability and monitoring. So the world is obviously changing. Coronavirus is the prime example of that. So how is your model going to continue to perform in an ever-changing world, given that many models can't be constantly, refreshed and retrained, and even if you can, the amount of data that you need in order to build a model, can be greater than the slices of data that you would want to train your model on. I think everybody building models right now for any kind of that is trying to predict any kind of behavior that's affected by COVID and lockdowns is in a bit of a pickle. Because if I train my data on the latest data when there were lockdowns, then after the lockdowns are ended, the models are probably not going to perform very well. But if I train my data on pre-COVID, then the model is not going to perform very well during COVID. So those would be conceptual soundness, explainability, unfair bias, segment level metrics, and model stability and monitoring.